Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be talking about 1.3, which is looking at rational expressions. So basically what rational expressions are is they're a way when we are doing operations involving certain powers or roots to kind of put it in a universal language that it's easier to do operations involving them, and we'll see that a little bit later. But for right now, 1.3, all I want you to be able to do is to convert between rational expressions and radical expressions, and I'll show that to you here in just a second. Okay. Basically what it looks like, another common title for this section would be fractional exponents. So we've looked at all kinds of exponents. We spent time reviewing rules of exponents, right? We have positive exponents, negative exponents, zero exponents. So now we're looking at fractional exponents. And so basically what this is, it's a shortcut for writing these rational expressions where A is going to be my power and B is going to be my root. So here's what this looks like. If I give you something like, let's say, the cube root of x squared, okay? That's a lot to write, especially if I was having you multiply that against something else or divide it by something else. And so what we're going to do, the power, to write it as a fractional exponent or a rational expression, we're going to put that on top. And then for the root power outside of the square root or the radical, we're going to put that on the bottom of the fraction. So if I asked you to convert the cube root of x squared, which sounds like a lot, but if I asked you to convert the cube root of x squared into a rational expression, all you have to tell me is x to the 2/3, and that's it. Okay, I can go through these all day. X to the 4th root of x to the 5th power. The power goes on top, root goes on bottom. Be careful, right? So if I had something like 5th and x, right, well, where's the power? Remember that if there's no power shown, there's always like an invisible 1 there. So this would be x to the 1/5. So half your assignment is simply being able to do that. It's meant to be an easy assignment today, so hopefully that one makes sense. Then we can go the other way also. So if I give you a rational expression and I ask you to write it as a radical expression, I'm asking you to go the other way. So for instance, if I give you x to the 3/7, okay, I'm definitely going to have a radical. I'm definitely going to have my x. Again, looking at these powers, my 3, that's a power. It needs to go here. So I'm going to write x cubed. And then for the denominator, that's going to be my root. So then I'm going to write 7 here. Okay. This is going to make a little more sense in application when we get into 1.4. But again, all I want you to be able to do for 1.3 is to be able to convert between the two. Okay. So just another example here. Let's do x to the 1/2. Well, that's kind of a little bit of a trick, right? You can still write them. The 1 is here. The 2 is here, but remember that if you don't have an index, is what it's called, if you don't have an index up here, then it's like it's a 2, right? That's just a normal square root. And similarly, if you have a 1 up here, you don't need to write it. It wouldn't be wrong, but simplified, we could just write this as square root of x, okay? X to the 4/3. 4 is the power, 3 is the root, okay? So again, hopefully this is an easy section, being able to convert either from radical to rational or rational to radical. But that's all I have for you guys today. If you have any questions, reach out to me. Otherwise, have a good day. Bye.